On this week's show, Liz traces her lineage with the help of DNA.
Everyone alive today can be traced back in time through their female relatives all the way to one common ancestor.
Dr. Yan looks at the science of dad dancing.
And this is actually my dad.
And Jem builds a singing road.
That's 2 metres done, so only another 248 to go.
That's Bang Goes the Theory, revealing your world with a bang. Hello there and welcome to the show. First up, we're going to be having a look at a couple of Jem's passions, music combined with a bit of welding.
There was a time before MP3s or even CDs when we used to listen to music by playing one of these, a record, a vinyl disc with a series of grooves cut in it. And within those grooves are tiny, weeny little bumps that make a needle vibrate as it goes over them. And that is where the music comes from. I love the fact that we can make music by bobbling things up and down over a series of closely spaced bumps. And it's got me wondering if we can't make music in a similar but bigger way. And just down here gives me a bit of an idea. Did you hear that? When I drive over that cattle grid, my tyre hits every single one of those rungs and it makes a vroom noise. And if I drive over faster, it goes vroom, and it's like a higher note. And I think there's a way of driving cars over cattle grids to play music. Can you imagine you get the correct spacing on the cattle grid rungs and the correct length of cattle grid, and I drive at exactly the right speed, it should or could play a tune. It's not wholly convincing at the moment, but I fancy seeing if I can turn my car into a stylus and a road into a record player. If I'm going to try to make musical notes by getting something like the rungs of a cattle grid to vibrate the wheels of a car, I need to know exactly how fast to wobble those wheels to get the notes that I need. And for that, I've got this. When I play a note on here, then that vibrates the air, and this microphone detects that vibrating air like an ear does, but converts it to an electrical signal that then comes out as a wavy line on here. And from that, I can find out how fast the air is vibrating, what the frequency of the note is. So, let's see what we need. I can read that the first note that I want is E. It's a G. Here's my G. And that tells me the frequency I need to wobble the air at to get a G is 196 hertz, which means the air's kind of vibrating 196 times a second, like that. So that's what the wheel of my car's got to do, which means it's got to be knocked by the rungs on the cattle grid 196 times a second. For easy maths, I figure if I drive at 20 metres a second, about 45 miles an hour, then that means for the one that's 196 knocks a second, that means in 20 metres, it's got to have 196 rungs. So I just need to divide 20 metres by 196. So it's about 10 centimetres per rung. So then it'll go, except a lot faster, and we should hear it as the note G. Making music this way seems great in theory, but the practical reality of it, once we did all the calculations, for just 12.5 seconds of music, it means we've got to lay about 250 metres of homemade cattle grid with rung spacings on average about 60 millimetres apart, meaning welded to this steel is going to be over 3,000 of these bars, each with about 4 welds on it, meaning 12,000 welds to do. That's a stack of welding, so I figure it's a good idea to test a short section before we commit to the whole 250 metres. Yes, I can definitely hear a note. I think we might be onto something. That's 2 metres done, so only another 248 to go. Oh, watch out for the hot bits.
OK, so you've got the G note down, but you don't speed up or slow down to get the other notes. You space out the bars?
No, I mean, imagine trying to drive.
Except the music in front of you going...
You can't do it. So to get a lower note, you space the bars out further, so it's like...
Okay.
And then a higher note, put them close together.
Loving the sound effects.
Let's talk about welding for a minute. How many welds went into that music?
12 to 15,000.
See, that's an insane amount of welding. I know you love welding.
I don't mind a bit of it.
Are you a better welder having done
You must
50,000
be.
welds in a row? Because that's...
I can sadly report probably not. The thing is, there's just so much metal to stick together in such a short amount of time. The bars have to be completely accurate, but the welds just have to be good enough to hold it together.
Is your workmanship getting shoddy, Jem Stansfield?
It's like the tailor of
Shocking.
Gloucester. You know, as time runs out, you just make the stitches fit.
Fair enough, fair enough. OK, next up, genealogy. And with the internet, you can get a lot of information these days. You can get birth certs, marriage certificates, census data, all that kind of stuff.
Tagged photos on Facebook.
Tagged photos on Facebook. But using a clever bit of science, you can also find out about one part of your ancestry and trace it back to over 200,000 years ago.
I think my family was still Gibbons back then.
I've never had a proper look at my genealogy, but here's what I know from talking to Mum and Dad and from some of the photographs that I have. So, first of all, here's me and my sister. There's Mum and Dad. On Dad's side, I've got Granny and Pappy. So this is Julie and Pappy, as we used to call him. I've actually got pictures of my grandmother's parents, Charlotte and Achille. And now my mum's side, this is Phyllis, my mum's mum. And this is Merlin, her dad. And, oh, this is Merlin's mother, my great-grandmother. I love this photograph. So that's about it. That's all I know. And this is where the science comes in, because there is another way I can find out about my mother, her mother before her mother before her, all the way back to the beginning of modern man, round about 200,000 years ago. And that's by looking at a little bit of my DNA. Genetics dictates that everything about us is passed down from our parents and from our parents' parents and so on, all through parcels of DNA called chromosomes. So it might seem possible that I could trace my DNA back through time to get to my distant ancestors. But tracing back your DNA is like solving a giant puzzle, because every child born carries a random mix of genetic information from their mum and their dad. Imagine this pretty puzzle broadly represents my genetic information, my DNA, and I'm going to try and figure out where all of it came from by only going back as far as my grandparents. Now, these are my grandparents on my mum's side. This is their DNA. They have my mum, and her DNA is completely distinct from either of her parents. It's a brand new pattern. Not only does she get a mix of both her parents' DNA, but each of her parents' individual DNA is also shuffled around in a process called recombination. And the same applies for my grandparents on my dad's side and my dad's DNA. Which means that by the time my parents have me, my DNA is completely unique. I can hardly trace it back to my parents, never mind my grandparents. And that's in just 3 generations. Now, extend that back by many more generations, and tracing the very origins of my DNA becomes very complicated altogether. But there is one solution. Not all of your DNA comes in the form of chromosomes inside the nucleus of every cell. Some DNA is also found in tiny little structures called mitochondria. They're basically the powerhouses of your cells. And the great thing is the DNA in your mitochondria doesn't get mixed up or recombined between generations, because you get them directly from your mom's egg cell, and you don't get any from your dad's sperm cell. So my mitochondrial DNA can only have come from my mother and her mother in turn, and so on back in time as far as you care to go. All of this provides an incredible opportunity for geneticists, a very clear window into our past. To look into this window, geneticists have been looking at mitochondrial DNA samples from across the globe and thousands of years back into history to create a giant family tree that spans the whole world. Now, the really brilliant thing here is that everyone alive today can be traced back in time through their female relatives all the way to one common ancestor, one woman who lived here in Africa 200,000 years ago, and she's known as mitochondrial Eve. Now, obviously, she wasn't the only person alive at the time. She was part of a larger group of humans, but she is the only one that every single one of us is related to through the female side of our ancestry. Scientists can work this out because although mitochondrial DNA doesn't get jumbled up between the generations, it does vary slightly between us. And it's these tiny but very important differences that can tell us an incredible amount about our past, how closely related we are to each other, where our ancestors lived, and when they moved around the globe. From time to time, people get harmless mutations in their mitochondrial DNA, just like they do in ordinary DNA. But because it's just one small change between mother and child, it's fairly easy to work out where it came from. Right then, imagine I live in Morocco, because I can't reach London from here. Now, I've got a brand new mutation in my mitochondrial DNA. I'm going to pass that on to my children. And if any of them are daughters, they're going to pass it on to theirs, and so on. And assuming that nobody emigrates from Morocco, that mutation will be localized and clustered in and around this country. But if one of my descendants does decide to emigrate to Spain, for example, they'll carry that mutation with them, and then their descendants will have it also. And the beautiful thing here is that you can link back that mutation to the people who carry it here in Morocco. By tracing these mutations, we can also work out the movements of the people who carry them. And it's this that has allowed us to work out how early man moved across the globe. And geneticists have created 30 main groups, a bit like the main branches of the human family tree. With all the information they've gathered from people's mitochondrial DNA around the world, geneticists can now map out the ancestry of each of those 30 groups. And now, by finding out which of those groups you belong to, you can trace the movement of your ancestors around the globe over countless generations, ever since the human race first spread out from Africa to populate the planet. The descendants of mitochondrial Eve.
I'm sorry, Liz, but do you not think that's just utterly mind-blowing?
I find it utterly fascinating.
The fact that we can trace our lineage back that far to this small group of people.
It's thanks to biology. It's a wonderful thing. Are you ready to find out about your ancestry down the females in your lineage?
I don't know.
You are, you're so ready, you're so ready.
Okay.
The boys and I got our saliva sampled and our mitochondrial DNA analysed, and here are the results. Okay, so as you know, we all started off in Africa, East Africa, the Rift Valley, 200,000 years ago, okay? And then only 300 to 400 humans, that's it, started moving north, out of Africa, okay? So 70,000 years ago, they moved across the Pillar of Tears into Arabia. Then they travelled along the coast of the Indian Ocean and ended up in the Persian Gulf. Now there they got stuck for a bit. It's thought it's because they were surrounded by deserts, but this is where it gets interesting. After about 20,000 years of being stuck there, we started moving towards Europe. Jem's ancestors and my ancestors are the same. 30,000 years ago.
Cousins.
Yeah, they moved through Mesopotamia, through Turkey, through Greece, through the Balkans, into Western Europe, okay? Then the Ice Age hit. It peaked at about 18,000 years ago when we had to retreat back into the Med and into northern Spain, and that's where all those cave paintings, those really cool cave paintings come from, okay? Then the Ice Age began to retreat about 11,000 years ago or so, and we moved back through Western Europe and into Great Britain. My ancestors actually went to the sun and hung out in Portugal. But I always knew me and Jem had a connection, cousins.
It's quite clear. It's a family resemblance, obviously.
Yeah, obvious. Fascinating stuff.
Yeah.
Do you want to know about you, though?
Okay, so I did something different?
Well, yeah, because when we moved west 30,000 years ago, you actually stayed here in an area called the Fertile Crescent, around here, okay? And your ancestors, invented farming.
Of course we did. It's on my CV. That's the first thing on my CV.
It's a beautiful thing. You planted crops, you domesticated wild animals, and you share the same ancestors as Dr. Yan.
Well, it's obvious, isn't it? It's obvious now you say it.
Remember, you know, his father is Chinese, but his mother is British, and it's the females in the lineage. So you have the same ancestors. And then finally, both your and Yan's ancestors moved 7,000 years ago or so to Western Europe. You followed Jem and myself, and you brought your agricultural skills with you.
Well, we thought you might find it useful.
We were the original hunter-gatherers, I have to say. I'm quite into that. It's a fascinating bit of information, there's no question. But you know the complicated, bigger picture of our entire genome? Finally, we are actually able to find out about our ancestry through that. Sophisticated computers allow us to do that, and because we've mapped the entire human genome. But we don't have as many samples of that as we do of mitochondrial DNA. The more samples we get, the more interesting the history of the entire human race will become.
OK, now all good weddings have a disco, and no wedding disco is complete without a drunk uncle or dad embarrassing their offspring with some slightly poor dancing. Fear not, Dr. Yan is on the case to explain the science behind this hideous exhibitionism.
I'm here at the Sadler's Wells Company of Elders dance group, and they're showing me some of their best moves, but I'm going to be showing them an incredible talent that they might not even realise that they have. So, hello everyone. Hello. First of all, what I'd like you to do is just look at this, actually. So, what do you think this is?
Is it a shape? A human shape? It could be a galaxy.
What if I do this? Yeah. Funny, isn't it? Because as soon as the dots start moving, it's really clear that it's people dancing. And that's because our brains are particularly well tuned to picking up movement, and in particular, human movement. When you watch something like this, you are actually processing it in a bit of your brain that you use to plan your own movements. And it's a bit like you're sort of mentally rehearsing it so you get a feel for the action and you can work out what's going on. But it's not just that. Do you think you could tell people's sex from the dance?
That's a woman.
So you think that's probably a female, yeah? And that one, possibly male, right? Okay. How about age? Which one do you think's over 60 and which one do you think's under 60? So you think this one's over 60?
Yes.
And this one probably under?
Yeah.
Yeah? Okay. Well, do you want to see who they are?
Yes.
Brilliant. Okay. Let's see. Moment of truth. Yeah. There you go. So you were right. This is Liz here. She's obviously a woman. She's under 60. And this is actually my dad. But he's over 60, so, you know. And so what do you think it is that you were picking up here?
You tell by her hips. Female.
Yeah.
She's using her arms more. I think she's fitter.
Yeah. You can pick up a lot of stuff, can't you, from the movement. So I'm going to show you another video. These are both men, okay? And I'd like you to tell me which one you sort of find more attractive.
Is this for all fellas?
Most of you initially went for that one because subconsciously we're sort of trying to look for signals that indicate whether someone's a worthy mate or not. And movement can give those sort of signals, And so it can act a bit like a mating display, really. Yeah. So basically, the best signs are those that only a good, healthy mate could make. Okay? Do you want to see who these are? Right, okay.
Hope the person doesn't ever find out what we said about it.
Well, let's have a look.
Practicing more dance moves.
Terrifying.
You're crying laughing.
Terrifying. Before we move on, can we just have another little look at Dr. Yan throwing his shapes?
Do it.
Have a look at this. This is brilliant.
Look at that.
Remember, this is the man who invented farming.
I'm having some rather weird, unexpected feelings for Dr. Yan. I'm not too sure what to do with them.
I'd keep them to yourself.
Yeah, I will.
Just when you think you know a guy, strips off and reveals a whole new dimension.
Indeed.
Absolutely.
But now time to hit the road. The singing road. What we did was try to turn a road into a record and a car into the stylus. Put them together and make genuine heavy metal music. It's taken 3 very long days, 3 committed people, and over 10,000 welds on 2 tons of steel. But finally, we've produced something that's going to turn our little piece of tarmac from a road into a record.
What is this?
This here,
Yeah.
they're a series of bespoke cattle grids.
Right.
That should have turned this section of runway into a singing road.
Is this just one note?
No, these are the tiny gaps between the notes here. So that's an E there, and that's a C. You go down there, and it'll hopefully make an utterly recognisable tune.
From here, just looking at it,
Yeah.
I'm going to go with Bohemian Rhapsody, Queen. I mean, that's just a ballpark.
Your job, Dallas, is to guess the tune.
You can hear the note changes.
Yeah.
I'd be lying at this point if I could tell you actually what the tune was.
Good, because
Yeah.
you're going far too slow. You're, no disrespect, only cycling kind of 8 to 10 miles an hour, whereas realistically, you've got to be going about 45
Right.
to get the proper notes.
OK, so what do we do?
Well, we need a better stylus.
Yes, and we need to go slightly faster.
Yes.
The problem with using a standard car is that there's always going to be 2 wheels on your little mini cattle grid, which means it's going to be playing 2 notes at once.
Yes, but luckily there was a company that made a non-standard car. They made this one, and it's got one single pickup there at the front. So provided at 45 miles an hour on an ice-strewn runway, I can keep that on a narrow strip of cattle grid, we're in business.
What could go wrong?
Well, it doesn't start very easily. Hold on a second.
Hang on.
You have to turn it like that, and then you have to let it back.
Give it some choke.
With a...
Bit of choke.
Thank you.
OK.
OK, I'm about to roar away now, Dallas.
OK.
Be very, very afraid.
I am very afraid.
This is the perfect vehicle. It's got one single pickup point on the front, just like a record stylus.
Yeah.
And that's just like the grooves on a record.
Some people might think that's a bit odd. Some people have a car stereo to hear their music. So what's the optimum speed?
About 45 miles an hour.
So it's almost like a 45 RPM. OK,
Yeah.
brilliant. It's a single.
Yes, it is indeed.
OK.
Ready? Go
OK,
for it,
here we go. Come on, Reliant Robin.
30 miles an hour.
We're going to go back to the future if we hit 40. Here we go. That is fantastic. Did you get it? Of course, it's the wedding. It's the wedding. That's fantastic. That is fantastic. That is fantastic. That is brilliant.
Dallas is absolutely right. It's the bridal march. The wheel of the car is knocked at the correct frequencies, and it plays the song that every happy couple wants to hear as they go down the aisle.
That was amazing. That's
All right.
it. That was really,
Just
really...
a bunch of mini cattle grids.
Yeah.
And a 38 horsepower stylus.
Maths is fantastic.
Yeah.
I mean, it's simple maths, really, isn't it?
Yes, and a vast amount of welding.
Maths and welding. Maths and welding.
And you're really onto something.
Does that mean we're officially married?
We're married.
It was getting quite romantic, wasn't it, in the old Reliant Robin?
Nice and cosy. Reliant Robin.
It's a Reliant
I always call
Robin.
it the Robin
You
Reliant.
mustn't,
I
because
know.
People, Robin Reliant... I just did it. Reliant Robin fanciers will get
Still,
terribly cross about
it does make a good stylist, doesn't it?
It does, but I mean, you don't see in the film really just how nail-biting that was.
Yeah.
Nobody knew with their hand on their heart whether that would really play a tune or not. It looked so unlikely, even on the day.
But also the fact that you put so much effort into it, you did so much welding for a fairly speculative experiment. I mean, we had, you know, the principle kind of work, but there was no guarantees.
And without
around
testing
yourself.
it on the full scale,
Yeah.
there's no way of knowing. I was overjoyed.
So now that you've got it down, are you going to make us some more tunes?
I take requests.
Good stuff. I'm going to make up a list. Okay, that's it for this week. We'll see you soon. Say goodbye, boys.
Bye.
Bye.